While revolving around the Earth, the Moon makes a right angle with respect to the Earth and the Sun, twice a month. This position occurs on the first and the third quarter of each month. On both these days, the forces of both the Sun and the Moon operate at right angles on the Earth. See figure 3.8. At the places where the Sun causes high tide, the gravitational pull of the Moon, which is at right angles, also act on the seawater. Due to such conditions, the water level rise is less than usual at the same time of high tide. Similarly, fall in water level is less than usual at the time of low tide. This is because the attraction of the Sun and the Moon are not complementary but at right angles to each other. Such tides are called neap tides. Neap tides are a little lower than the average high tides and a little higher than the average low tides. Effects of tides. With the high tide, fish move into the creeks and this helps fishing activity. The tides clear the west and hence the coasts become clean. Ports do not get filled with sediments. Ships can move up to the ports during high tide. During high tide, seawater can be stored in salt pans from which salt can be obtained. The tidal force can be used to generate electricity. A lack of an understanding of the timing of high and low tides may cause accidents to steamers entering the sea. The tides help in maintaining the mangroves and the coastal biodiversity. Timings of the tides change daily. The tides are continuously occurring phenomena. After reaching the maximum water level during high tide, the low tide sets in. Similarly, after reaching the lowest water level during low tide, the high tide sets in. Remember that in the following discussion, the highest limit of the high tide is mentioned. See figure 3.9. You'll understand why the timings of the high and the low tides change daily. There will be high tide at point P as it is opposite to the Moon. As point F is opposite at an antipodal location to the point P, it will also experience high tide at the same time. It will take 24 hours for point P to come back to its original position, 360 degrees. Point P will be at point F after 12 hours, 180 degrees. The same change will also occur with reference to the point F. Point F will not experience the same high tide because in the meanwhile the Moon also would have moved a little ahead, approximately 6 degrees 15 seconds. Hence, it will take 25 minutes more for the point F to come to the position opposite to the Moon. After 12 hours 25 minutes, F will arrive opposite to the Moon and it will experience high tide. Point P opposite to F will also experience high tide. Later again, after 12 hours and 25 minutes, point P1 will experience high tide as it comes in front of the Moon. There will be high tide at F12 as shown in figure 3.9. There is high tide and low tide twice a day, 24 hours generally. The time difference between two high tides is 12 hours and 25 minutes. Geographical explanation. Waves. If you blow air over hot milk or tea while drinking, ripples are generated on the milk or the tea. In the same way, Because of the force of the wind, water appears to be moving. The seawater gets pushed by the wind and ripples are generated on the water surface. These are called waves. The seawater moves up and down or slightly forward and backward due to the waves. The waves bring the energy contained in them to the coast. They break in the shallow waters near the coast. Large or small waves are formed continuously at the surface of the sea. Generation of waves is a natural and regularly occurring phenomena too. See figure 3.10. Structure of the waves. The seawater gets pushed up and down because of the wind. The raised up portion of the wave is called crest and the depressed one is called trough. If a strong wind is blowing in one direction, large waves are generated. The vertical distance between a crest and the following trough is called the amplitude of the wave, whereas the distance between the two successive crests or troughs is called the wavelength. The wavelength, its amplitude and its velocity depend on the velocity of the wind. See figure 3.11. Velocity of waves. If we stand at the coast, we feel the waves are coming towards the coast. If a floating object is thrown at a distance in the sea, we find the object moving up and down at the same place. It does not come to the coast. It means that the water forming the wave also does not come to the coast. Remember that the water in the wave does not move. What moves is the energy. The main reason of wave generation is wind. But at times, due to earthquakes or volcanic eruptions occurring below the floor of the sea, waves get generated. Such waves assume a great height in the shallow waters near the coast. These waves are very destructive. They cause huge loss of property and life. These waves are called tsunamis. In 2004, tsunami waves were generated because of the earthquake that took place near Sumatra Island of Indonesia. They devastated the east coast of India as well as of Sri Lanka.